My name is Kory. I'm with the iRODS Consortium, and this talk is going to be on GenQuery2, providing a more standardized, powerful parser for the iRODS namespace. As always, we have an overview slide where we're going to cover several different things. These are the things that we're going to cover. We're going to explain what GenQuery2 is. We're going to talk a little bit about the repository, general features, components, providing a couple of examples. Then we talk about remaining work in the community. So first off, what is GenQuery2 exactly? This is an experimental redesign of the GenQuery1 parser that everybody is familiar with. This project exists as a way for the community to get involved with the development of this new parser, because we really don't want to put something out, and we really don't want to make this part of the server without it being really stable and offering all the features that people want, as well as resolve all the existing issues that people have gripes with when it comes to GenQuery1. And so we want to get, the way we do that is by getting closer to standard SQL, and so that people who are familiar with SQL and people who are not can always refer to it. People who are familiar with SQL will feel comfortable using this syntax and this parser. So just a bit about the repository. All of the things I'm going to cover in this talk are pretty much housed in this repository here. If you're curious about the implementation and details about how to use it, you can go visit this repository and read the code and everything else. Things we're going to cover in this talk specifically are the API plugin, the rule engine plugin, and the iCommand that's provided by this package. So here are the lists of features that are provided by this new parser. All of these things work today as is. It enforces the iRODS permission model. It supports all of the logical and or not operators. You can now group things using parentheses in whatever way you want. There's no magic around the grouping of metadata anymore. It also supports some additional things such as casting, group by. It also gives you the ability to specify an upper limit on the number of rows that are returned. And you can also mix and match different metadata-based queries. So that means that you can now, instead of having to run a different query for collections, and then you got to turn around and run another query for resources or users, you can just run one query and it handles all of the joinery for you across any number of entities within iRODS. All right, so our first thing here that we're going to cover as far as components go is the API plugin. This is essentially the entry point that wraps the parser and makes it available to all libraries and clients. It essentially consists of an API number. We have here also the input parameters, which is a query string, a zone, and an SQL only flag. Query string is exactly what you imagine it is. This is the query that you want to run. Zone is an optional parameter that you can use to specify, hey, I want to run this query in some federated remote zone, right? And SQL only is essentially a Boolean value, which you can use to tell the API plugin, just give me what you would run, right? And we'll see examples of some of these things later on. As far as output, on success, you get a JSON string representing the actual results. So then you can just use your favorite JSON parser to interrogate that result set. And on failure, you get an iRODS error code with information about what led to the error, possibly. That's something that we have to flesh out more. As of right now, this defaults to returning a max of 16 rows. This is just a number we pulled out the skies. Can be changed as just default value, just to protect people from producing result sets that are perhaps 100,000 rows, right? And blowing it, basically resulting in out of memory errors or whatever, right? Next, here is the rule engine plugin. This is, you may be wondering how we can expose this to the native rule engine plugin. Well, the only way we can do that with 4.3.0 and earlier is by using a rule engine plugin, because this gives us a space to store information across different rules. Those rules being GenQuery2 execute, next row, column, and destroy. These are all of the rules that are provided by the rule engine plugin. And so these are what you would use to access the actual parser. When 431 becomes available, this requirement as far as having to install and configure a rule engine plugin will be lifted, because now 431 provides a new data type called process stash, which allows anything to store arbitrary information inside of it, and it can be reused. So you can think about this as temporary storage being available across a number of facilities throughout iRODS now. All right, so here we have an example of showing how you would use the rule engine plugin to gain access to run GenQuery2 queries. Essentially, you would just install, just like any other rule engine plugin, this rule engine GenQuery2 instance, and then you can you can run GenQuery2 code. So here, we're just going to walk through how you would use this. This line here just provides an example of, hey, we're going to execute some GenQuery2. In this case, we're going to select collection name, data name, and we're going to order it by data name, but in descending order, and we're going to only limit it to one result. You know, not very useful, but this is just to emphasize how you would use it. Upon success, you would get a handle back. Will be all right. So mute it. It's good. Okay. So here we would just use GenQuery2 next row to iterate over the results. As you notice, it's wrapped in a call to error code because we don't want this to fail, because this rule is designed to return a negative value when it reaches the end of the result set. And so this is essentially just moving a pointer that's internal to the rule engine plugin forward. And so just like any other programming language, you see this pattern a lot in something like JDBC. And so you call next row, and now we can go into actually fetching information from our result set. We can do that using GenQuery2 column, which allows us to basically pass an index and say, hey, I want the first column, or I want the third column, or whatever, and it fills that information into the variable that's passed in. In this case, we extract the collection name and data name, and then we write that out to standard out. And the very last operation here in our usage example is that we need to call destroy. We need to make sure that we clean up behind ourselves, because if you fail to do this, you've basically just leaked memory, because this is memory that is stored in the agent, and it won't be released until you call this function or this rule, or the agent goes away. And so you really want to make sure that you are doing the right thing and cleaning up behind yourself. All right, so our next thing here is the I command that's provided. Here, this is just a binary which enables execution of GenQuery2 at the command line. Here is the help text that you will see if you were to run iQuery-H. We try to format it to be similar to man pages, because it's familiar to people. And so, as you can see, it's very simple. It's basically mapping the API plugin to a binary, so that people can just run arbitrary GenQuery2 calls. So we'll show an example of this here. So in this example, we're going to make use of JQ so that we can get a formatted output. But essentially, we have here a query in which we're going to show how you can use group by to list the number of replicas for all data objects within a zone, right? In this case, this is the local zone. And so this looks very much like normal SQL at this point. We run this query, and this is the raw, and below you'll see the output of the command showing what you can expect. All right, here's another example in which we're going to run the same query and see what the actual parser generated. And so I think that this is going to turn out to be a very powerful feature for people who want to know exactly what the parser is producing, so that they can debug what they might be doing wrong, or why they're getting results that are unexpected. In this case, we also use PG format so that we can get a nice formatting of the SQL so that it's easy to understand. Another important thing here to notice is that GenQuery2 is also, as you can see, is producing all the joins and all those things. And some of these are predefined because we understand the actual schema of the database. And so we don't have to be so, we can simplify things and make it, this is what allows us to get more, provide the ability for people to actually change and enhance the GenQuery parser over time. All right, remaining work. So before this can be absorbed into the server and shipped with the next release of iRODS, we have to do a few things, such as we want to clean up the CMake list file, obviously, but we need to implement tests. We also are having discussions around how to best support groups and tickets. Like, do we provide the same functionality that people see in GenQuery1, or do we take it a step further and allow people to maybe determine just using GenQuery what users are part of a group and maybe what groups contain some users or whatnot. We also, with tickets, there's a discussion around, should you be able to resolve tickets? If you know the ticket string, should you be able to resolve it to a logical path freely, or should that just be restricted? Because in GenQuery1 today, you can resolve the path of a ticket to a collection, but not a data object. So it's a little weird. And so that we're having conversations around that. If you're interested in any of these topics, please join in on the conversation at these issues. As for future plans, we want to continue to expose more SQL features such as case support, having clauses, sub-selects possibly, support for multi-argument functions such as concat and various other SQL functions. We're also considering providing maybe syntax for disabling certain features in the parser. So here's just an imaginary example of iQuery option distinct off. This is not supported today, it's just imaginary, it's not real. But this is the type of thing that we're thinking about. And we're considering switching from boost variant to standard variant, which is C++ stuff, but you know, it's just a thing that we're thinking about. And one of the last things here is that we have to think about pagination support, because this new parser does not, its goal is not to protect people from, you know, out of memory errors. Although we do provide safeguards for that, the thing is that there's nothing stopping a user from requesting a million rows, right? But also it's not designed to allow you to, it's not going to handle paging for you. And so we have to build facilities around how to do that. Maybe that is provided through a set of APIs or libraries that we provide, or maybe we just provide a document explaining how to do this and then people can go and implement it themselves. As for community engagement, so we really want to get feedback from people on this project, because we don't want to add this to the server and it turns out to be it turns out to be horrible, right? We don't know what kinds of queries people are running. And so one way we are looking at increasing engagement is by possibly releasing an experimental package. But there's some things that we have to think through. If you install this package, how do you, once you upgrade to a server that supports GenQuery2, what happens then, right? And so we need to think through how we best handle those use cases like that, right? So yeah, we really want some feedback from the community here. And with that, I think that wraps up this presentation. There's another talk that we gave at iRODS with details about the actual implementation and what we went through to make this work. If you're interested in that, you can look at the slides and click on the iRODS link, or just visit the iRODS page. And I think that wraps up this talk. Thank you. All right, any questions?
Thank you, Kory. I'm asking a more general question because I've been asked that question about iRODS. And is iRODS a data lake? And when I see some of the capabilities that we have, I personally hate the word data lake, just for the record. But when I start seeing what answers you can get from GenQuery for certain things, and the exploration that you can do to understand what your data holdings are, where they are, what's the coverage. Have you sort of thought that if you had to explain someone the use of GenQuery and iRODS together, is that something that can be considered as a data lake?
I don't know.
Yeah. It's just a thought because this question gets asked many times and everybody's pitching object stores now as data lakes. And now we have data lake houses, which really blows my mind.
Lake houses, yeah.
Yeah.
Nice.
So what we can do with iRODS is vastly more than what my institution does with their data lake, which they pay a fortune for. And they can barely do half the things you can with iRODS. But the GenQuery part that you showed is what they rely on so many other applications to give them an understanding of what are their, like, what is the data from this department that could be used for something that, what was the last time we got some data from that group? You can answer those using GenQuery very straightforward.
And I think data lakes generally can't unless they actively write all that down, which most.
Oh, so that's what I'm saying. They want that from the data lake. They can't do it.
Yeah.
GenQuery has that, and we already keep flat files and objects. So is there value in telling some of the industry partners, yes, you can also build your data lake on iRODS. Come have fun. Just thoughts.
Why not?
On the paging, is it built into the API yet to do auto close after, retrieving a page and, do successive calls with offset and limit, to do that style query? I'm thinking specifically of when you have like a RESTful client where you're going to open and close and you want to pull. So in other words, safeguards for avoiding the agent going off in some weird stateful behavior and giving you query rows when you're asking it to do something else, like that kind of thing.
GenQuery2 is essentially, it's a very, like, the parser is where all the work done. The database part is just, hey, we're going to open up a connection, run the query, and get the results, and we close it. It's done. It's nothing else, but it supports offset and paging. Offset and limit. And one of the things we thought about earlier was that we looked at other APIs that dealt with this kind of thing, and they provide things like, they remember the last row that was returned in the result set, right? And if you pass that in, then you skip everything else, right? Well, you can do that here, but we might not know how people what keys they want to key off of, right? And so we gave people the option to, we left that decision up to them by just providing the ability to specify how many rows do you want. You can sort it by whatever keys you want, and then you can specify, offsets and whatever else. So you have freedom and flexibility here to do what you want.
Okay, yeah, so that was just like a client challenge was with the stateful agent when you're done with the query, but it still has results that you might want to return to. The other thing was, are you targeting like a database or do you have like plugins for MySQL versus Postgres, or are you doing any sort of cross, for different databases? Is there a notion of having a driver for?
So in this, in the internals of the API, the actual API plugin it looks at the server's config because the API itself accepts a set of options that says, hey, I have a database option. If you tell me what database you're using, which is required, it will adjust all its queries to make things work how you need to. And this is not a compile time thing, this is a runtime thing. And that's by design because it just simplifies things, right? We keep all the logic that is where we care about what type of database we're dealing with local to each other, right? And that way you can see just above, like, oh, there's Postgres, oh, and here's MySQL, and here's, there's some other database. And so now you don't have to look very far from the piece of code that you need to touch to make decisions or adjustments for a particular database.
Yeah, but the plugin architecture was already there. This is just a different parser that's actually a real parser, which means it's actually maintainable and flexible. And now Kory knows everything, so it's going to be easy to handle.
Any other questions?